Awesome. So let me just share my screen with all of you guys. Look good?
Yeah.
All right. So, hello everyone. My name is Christine, and I'm a PhD student at the University of Toronto in the Technologies for Aging Gracefully lab, working under Cosme Munteanu. So my research is focused on the design of conversational voice interfaces and the development of tools to help designers to develop good voice user interfaces. My research also focuses on improving VUI design training in HCI education, which I'll be talking about today. So today I'll be talking to you all about the state of VUI training in HCI education and why it's important for HCI educators to incorporate VUI training into their curriculums. So, as I'm sure we all know, VUI interfaces are growing very quickly in the commercial market and becoming much more commonplace in our daily lives. They're in our phones, they're on our desks, and they're in our cars. Some are taking over healthcare. As you can see, tech companies want your smart speaker to take on healthcare. Some you can talk to just like a human. If you guys haven't heard of Google's Duplex, that one's pretty cool. Babies are starting to say Alexa as their first word, which is quite fascinating. And some even let you talk to your toilet. At CES 2019, there was an Alexa enhanced toilet, which was pretty cool as well. So devices like Alexa and Google Home are everywhere these days, as voice is seen as a natural form of interacting with technology and is often touted as the future of interaction. However, are these devices working well for everyone? If you haven't watched the Italian grandma learning how to use Google Home, as depicted here, I encourage you to do so and ask yourself, how does it work for her? Is it working properly? Is she having a good interaction experience with the device? We're finding that with the growth of voice user interfaces, there is an ever-growing challenge for designers to properly design for voice interaction. This job currently falls to designers who have already gone through a lot of training to learn how to design for user interfaces. However, we're still finding that voice user interfaces have a lot of usability issues, as research shows. Why doesn't it work very well, though? We have many other good interfaces, and we've been designing them for decades. So why doesn't it work the same way as, for example, graphical interfaces? How do we design graphical interfaces? We've currently gotten to a point where graphical interfaces are so well designed and usable. For example, the design of a touch-based smartphone like the iPhone. We've built on and iterated and developed very usable interaction with graphical interfaces like these. However, now new interaction techniques like voice are appearing. And current research, as I mentioned before, shows that they don't work quite as well as we would want. Who is to blame? Do we blame the designers? Or maybe, do we need to take a little closer of a look at the training the designers receive? As voice user interface design progresses, designers need to be properly trained to design for voice interaction. How are we helping designers adjust to this new interaction technique that they have to design for now? And how do we train new designers to be ready to design for voice interfaces? So we've been teaching about how to build good graphical user interfaces for a while now. The courses that I've listed here are just some of the courses that we offer at U of T that teach about good user design using established HCI methods. And you may have taken or even taught similar seminars or courses. In fact, the education and training that many designers have received so far is driven primarily by graphical user interface design as of now. Much of the methods and guidelines that we currently teach are based on GUI design that were developed decades ago, things like Nielsen and Norman's guidelines, so on and so forth. Even our assessment methods and prototyping methods that we teach currently work primarily for GUIs. How do you do a think aloud or a paper prototype with a voice interface? So the main question that we explore in our paper is, how is GUI design being taught in HCI education? Are we teaching it at all? How are we teaching it? And what do we have to start with? To do this, we performed a study that consisted of 2 phases. The first was a scoping scan of 25 international universities, identifying potential GUI courses. This involved going through all the HCI courses in respective departments and scanning through both their title and their course description. The second phase involved a more in-depth syllabi and course material review of a selection of these courses. The overall goal was to identify how much of current HCI courses discuss or are dedicated to GUIs, and what about GUIs is being taught in HCI education. So to identify the courses that discuss GUIs, we use these keywords, which were taken from a previous systematic review on the state of speech in HCI. If a course title or description contained any of these keywords, it was identified as a course that discussed GUIs. The goal here for the first phase was to gather a rough overview of the courses that had GUI concepts incorporated into them. So this chart shows the universities and the courses, the amount of courses in each university that we reviewed. So institutions were selected according to the number of CHI publications in 2018 and 2019 to get a rough idea of universities that are highly involved in HCI. And the departments that the courses were part of largely encompass computer science and iSchool departments. So through all these universities, we reviewed every HCI course that they offer, and we identified based on the keywords how many of those courses discussed GUI or GUI design. As you can see, only half of the universities contained at least one course that discussed GUIs, and almost all of the ones that did have something had only 1 to 2 relevant courses. So as we can see, not all of them teach GUIs. So let's break this down a little bit. From the course titles and descriptions, we found 5 main topics among the courses that contain these keywords: artificial intelligence or intelligent interfaces, emergent or future interfaces, human-robot interaction, multimodal interfaces, and speech interfaces. So these were the main course topics that the courses that talked about GUIs, these are how they were framed. In our second phase, we wanted to look deeper into these courses to explore the amount and the focus of GUI discussion in them. So we performed a syllabi and course material meta review with 10 courses, which is shown on the chart to the right. While we identified 20 courses in the scoping scan, we were only able to get the course materials for these 10 courses from instructors to review. So we identified 4 main themes, which I will talk about next. The first theme was the course materials that were related to GUIs. We identified 3 main types of course materials: assignments, lectures, and readings. So we found that 3 out of 10 courses had a practical GUI assignment. 4 out of 10 courses had at least 1 lecture dedicated to GUIs. And 5 out of 10 courses had some type of reading or reading list dedicated to GUIs. The next thing we looked at is the breadth and depth of GUI coverage in these courses. The full details are in the paper, but just a few highlights. An average of 12% across all courses that have GUI lecture materials were dedicated to GUIs, with the largest amount being 35% in one course. For the courses that did have VUI assignments, each of these courses had about 4 to 5 assignments in total, but at most, only one assignment was dedicated to VUIs or CUIs. And as we saw in the last slide, that was only 3 of the 10 courses that we reviewed. The third thing we looked at is how VUIs were framed in these courses. Again, some main highlights. We found that VUIs were often framed in the context of artificial intelligence or intelligent agents. In relation to that, there was a large focus on natural language computation and dialogue systems when it came to talking about voice and conversational interaction. And finally, as is the focus of our research, we wanted to explore how much coverage there was on VUI design in particular. We found that only 4 courses discussed VUI design, particularly interaction design. The rest discussed VUIs at a high level. There was a large focus on dialogue design, with one course discussing dialogue design of text chatbots in particular. And finally, only 2 courses actually taught about designing for a voice-based interface. Others talked about conversational interfaces in a medium-agnostic way, or focused particularly on text chatbots. So what can we learn from all this? We found that there is an evident lack of VUI design training in HCI courses right now. As our review showed, most of the conversation around VUIs in these courses did not focus on instructing designers on how to design for these interfaces. There's a lot of current research on VUI design that we can start to incorporate, but this will likely also require developing theoretical, pedagogical tools that can be adopted into practical training. Guidelines, design patterns, assessment methods, etc. Developing these takes time, and we feel it's necessary to start working on these now. There's also little focus on voice-based interfaces. Often, the medium is not specified, or only text-based conversational interfaces are focused on. However, there are unique usability issues with using voice in particular that need to be addressed. As well, there is little focus on interaction design. Often, when there is any discussion about developing these interfaces, the focus is on dialogue design. Dialogue design is very important, but there are other usability issues such as feedback, learnability, and more that need to be focused on. In conclusion, we want to call on the HCI community to take a step forward into further incorporating VUI design training into HCI curriculums. If we don't incorporate VUI design into our courses now, there are consequences which will be more difficult to solve as more and more voice interfaces end up in consumers' hands. As mentioned earlier, the development of pedagogical training tools is also essential in teaching designers how to design for VUIs in the same way we have them for GUIs. This, of course, extends into industry training too, something we plan to look at in the future. Speaking about the future, we plan to conduct future work that will involve interviews and collaboration with both HCI educators and voice interface designers. We would like to hear from you about how to develop a curricula for VUI design and what is important to incorporate into a VUI design curricula. So you may hear from us soon. If you're interested in being a part, please feel free to shoot us an email at any time. Thank you.
Good. Well, thank you very much, Christine. So I'll invite people on the call if they want to ask a question or make a comment. They can either unmute themselves and do that, or you can just type in the chat and I can read it out. Yeah, so maybe to kick things off, Christine, a very interesting talk. So you found there wasn't a lot of coverage in the curriculum of VUIs. Do you think, is it the case there's just not a lot of material out there in terms of guidelines or work that could be put in there? Is there more, or is it just more that the material exists, but it's just not in a form and it's just not included in the curriculum?
I think there is definitely a lack of guidelines, as you mentioned. Something like we teach heuristic evaluation, for example, in our courses. That's a very popular usability method. But in order to do that, you need guidelines. That's something that doesn't exist in a large scope. We have things like to-do lists, like these are 10 steps to create a voice user interface, but we need something at a bit of a more theoretical level, something more foundational that can help us and help make voice interface design consistent. I think it is also about HCI educators. They also need assistance to be able to help incorporate these. There are likely barriers, both in knowledge and tools available, and this is something that we want to help with.
Good, great. Yeah, I see a question in the chat here, so I'll read it out for you, or you can see it yourself if you wish. But it's is the reason that there's not much VUI education because of it? It's a commodity and not shared by businesses, you think?
I'm not quite sure about that. I mean, I think industry training is also very important, and that VUI design training, it would be really great for that to be incorporated into industry and into businesses. This is not something that we looked at in the scope of this study. Industry and business is something that we would like to also explore because we realize it's important, and that's also why we want to ask people both in academia and in industry to help us with this.
Right, right. Yeah, that's a good point. Yeah, and I'm not sure if that's exactly what the nature of this question was, but a question that I guess that is inspired from that is, I would imagine there's people who, I mean, there's lots of consultancies and other organizations that offer training on different UI UX topics, and you know, I would have to imagine if there's someone that's got an offering on VUI design, like a one-day workshop or one-week workshop or whatever. It might be interesting to see sort of what they're covering, and you know, because maybe obviously some overlap with what you want in a school curriculum.
Oh yeah, absolutely. And you're right, there's absolutely different workshops being offered, either one day or 1 week, or offered kind of in an encapsulated sense. And this is something that we've been looking at, and this is something that we want to write about also. But I agree that it's very important to look at those as well. And we're hoping that we can take things from that and also incorporate them into an actual curricula as well. So I definitely agree there.
Good. Oh, there's another question or comment here. Yeah, so I guess the question is, I don't know if in talking to these universities about what their curriculum development is, are they, as they develop these, are they working with companies like Google and Amazon, do you think, to as these in the ones that you've looked at? Like
I'm not sure at the moment. I think that will involve interviews and discussing with these educators. Right now, what we did in the study was mostly just looking at materials. So when we contacted instructors, we just asked for a syllabi and any reading lists or assignments. But I think that's a very interesting question that would be very worth asking when we plan to hold more in-depth interviews in the future.
good, great. Okay, if there's no more questions or comments, we'll move on to our next presenter. So that's Brian. Over to you, Brian. And if you could start just by giving us a bit about your background before you tell us about your talk.
Yeah, sure. So hi, everyone. My name is Brian Wan. I'm a second-year master's student here at the University of Toronto, and my advisor is Toby Grossman. And I was really interested in wearables interactions last year, so I did this project, BlinkSync. I'm gonna share my screen with you. Okay. Do you see it? Can you see the screen, Paul?
Yes. Yep.
Great. So this project is called BlinkSync, enabling multimodal smartwatch gestures with synchronous touch and blink. Devices. We're living in an age where we are surrounded by numerous devices, right? And we humans are able to interact with them using quite a variety of ways. For example, touch input is arguably most used input nowadays. because it's quite intuitive, supporting direct manipulations of object. And speech for sure, as seen in Christine's talk. We have Alexa, Siri, Google Assistant. And apparently we're now much more used to seeing people talking to this black cylinder now than ever, right? We can also use our eyes to interact with devices. For example, a few months ago, I saw many people start to use links to play Flappy Bird, which was super fun. And you might wonder why we have this many ways to input signals to devices. It's just because we can. Well, it's kind of true, right? But another reason is that there's no single perfect input modality for all using scenarios. Every input has their limitations. For example, we know that touch input is convenient and easy to use on a tablet or mobile phone. But when the screen size being reduced to the size of a watch, it becomes a totally different story. Selecting items on smartwatch with fingers becomes notoriously difficult because the finger could easily occlude the screen, and the items might be smaller than a fingertip, make it hard to select. So prior research has tried to increase the receptive area of the touch input. For example, projecting buttons onto the screen, and the users can interact with the watch by pressing those projected buttons on the screen. As well, we can decrease the contact area of the fingertip to increase the precision of the selecting items on the screen. And this paper, Nano Stylus, is actually from DGP and Autodesk Research here in Toronto. And it puts a stylus on the fingertip to solve the fat finger problem. So that's for touch input. Another great example is eye-based input. You know, eye input provides subtle, instant, and hands-free interaction. What you lose is what you get. And it sounds like an excellent input to interact with devices. But humans' eyes are meant to serve as perceptive organs and did not evolve to be fully controllable. So as such, they're prone to false activations. Everywhere you look, another command is activated, namely the Midas touch problem. So if each input is limited, can we combine them together to solve each other's limitations? Actually, combining eye plus touch input isn't the news. Prior work has investigated how to use these two input modalities sequentially to enable novel interaction. So in this paper, users can use their gaze to select an item on the tablet and use touch input to manipulate the item. And since gaze can move faster than hands, it could improve the efficiency when using a large tablet. So it's gaze select, then touch manipulate. Similar idea has also been investigated in a desktop setup. So a user can use their gaze to move the cursor instantly between distant area on the screen, then use the mouse to fine-tune the selection. So in this case, it's gaze select, then cursor fine-tunes. These are all amazing work, but the eyes were usually only used to supplement the primary inputs, and the inputs were mostly used sequentially, right? Like we saw that gaze select, then use touch to manipulate. So we wondered, why don't we let the two input modalities complement and reinforce each other's? So we hope to use touch to reduce the false activation problems for eye-based input, as I mentioned before. And we want to use eye input to augment the touch input, where the input expressivity is limited, for example, when using a smartwatch. So our proposed solution is a mutual delimiter. So a bit about the background information. So what is a delimiter? Let's say we have a timeline here, and we have a series of input signals. It could be keyboard, or it could be touch input or mouse clicking. Then the use of a delimiter is to delimit a certain interval which the input would have different meaning or functions. So for example, the control key is a great delimiter for desktop usage. When you press the control, then and click the items, that the functions it performs will be different from clicking without the control key pressed. So what is a mutual delimiter here? Let's say we have signal 1 here, okay, and it's delimited by another signal. And at the same time, signal 2 is delimited by signal 1, while it delimiting signal 1. So in short, it means that they both delimit each other at the same time, and therefore to increase their increase the input vocabularies or solving any potential false activation problems. So our goal was to find out a gesture set that use both blink and touch input, and could potentially serve as mutual delimiter to enhance both input together. So we looked at a larger design space of eye plus touch input. Firstly, we could have blink and touch with different durations. So we can have long touch, short blinks. Then the blink and touch events could happen in sequence, right? You can have blink then touch then blink. And you can also have multiple events in sequence. For example, you can have blink, 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 touch, or touch, blink, touch, right? These are all possible gestures. They can also happen at the same time. And of course, there are 3 types of synchronizations here. So if 2 events happens at the same time, they are synchronized. And there are 3 types of synchronizations here. They have synchronous starts, or they can have synchronous ends, or synchronous starts and ends. So it really depends on how, whether you consider both ends of the events, or you only consider the start or the end of that event. Okay, so that's for synchronization. And lastly, we can have different kind of touch gestures. And of course, the eye expression like gaze or blink and wink, right? Then we have this large design space, and then we have to narrow down this design space to better design our gestures, because we don't want to have a super complex set of gestures. So firstly, we hope the gesture could be performed rapidly. So we only consider short events. Then we wanted the 2 inputs can delimit each other at the same time. So we don't consider sequential inputs. So the event sequence was deleted. And also we did not consider gaze in our design, but we will demonstrate how it could potentially be incorporated into this technique. And then we discard wink, because it's not easy to perform. It's not that accessible for everyone. I know some people couldn't do that. Yeah, so then we have the final design consideration here. We want the gesture to be short, synchronous, and blink and touch event. Therefore, we present blink sync, a gesture set enabled by performing a pair of synchronous blink and touch events. So here's how it looks like when performing the gestures. Great. So it's super easy gesture, and it's not easy to perform. You can try it out right now if you want to try. Yeah. And then we have this gesture in mind. Then we must answer the questions here. Is it easy to perform the gestures? Because the user needs to do 2 things at the same time, right? They need to blink and touch. And how often does it appear involuntarily? Because we know blinks would happen spontaneously. So we want to know whether this blink and touch, blink sync gesture would happen involuntarily. So the question is, how often would a synchronous pair of touch and blink happens in natural use? So to answer the question, we first conducted a 12-participant user study, gathering the blink and touch data during normal use. So we had 4 tasks in this study, 2 with smartwatches and 2 with papers. and I'll go into detail later. So the reason why we have both smartwatch and paper task is that we want to look at, is there any difference between the platforms in terms of the eye blink activities. So for the smartwatch, we have the first task is using a calculator. So it's basically typing a formula on that calculator app. So this app elicited intensive tap interaction in the task. And the second task for smartwatch is reading news from newsfeed. So the user had to press the title of that news and read through the text. So this app elicited a combination of tap and drag or swipe touch interaction in this task. And for the paper task, we got the first task is solving a word puzzle. So the user will be using a pen to mark the word they found. And this last task is reading an article. So the reason why we designed this task is that we want to have different level of the intensity as well, and we want to look at different platforms. Okay, so during the task, their eye was tracked. So we tracked their blink events, and for smartwatch task, we also track their touch events. So here's the stats breakdown of the rate and duration of both blink and touch. So for touch rate, using a calculator is harder, and for the duration, the touch duration, reading news is longer. These are all as is expected because calculator requires more tap input, where a news feed elicit more drag and swipe input when reading the news. And for both smartwatch and paper tasks, the blink rate dropped when the task intensity increased. And the blink duration were consistent across different tasks, but it's a little bit lower for solving the word puzzle because it could have potentially been due to a heavier visual workload because you're, very concentrated on searching the words on a relatively large area compared to a smartwatch. So remember that the goal of this study was to find out how often would a synchronous pair of touch and blink happen, right? So we need to first define the synchronicity, right? So the synchronicity is defined by both start offset and end offset. So the start offset was the start time of the touch minus the start time of the closest blink. And the way to calculate the end offset is the same. And we have this formula, then we can calculate the offsets for every data point. And the results showed that users actually rarely performed synchronous blink and touch when they were using smartwatch. So if we set the threshold for both start and end offset to 250 milliseconds, we actually get 1.68% of possibility for the occurrence of a pair of synchronous blink and touch. So it's a good news for us. And we also found that if we consider both start and end offset, we'll get a lower false activation rate compared to only consider start or end offset individually. So based on this result, we chose to look at both start and end offset when defining the synchronizations for the gesture. So we have this final blink sync gesture that consists of blink synchronized with either a tap or swiping for directions. So now we have this gesture set. We have to answer the question that, is the gesture set easy to perform? So we conducted another study to find the answer of this question. So the question was, were the users able to synchronize these two channels of signals? If so, how accurate it is? And firstly, we have to choose the threshold to define the synchronization for this gesture set. So as I talked before, we chose 250 milliseconds as the offset threshold to define the synchronicity. And oops, I need to just 1 second, sorry. I think there's a guess there are some, oops. Okay. Sorry for that. There are some technical issues here. So yeah, we chose 250 milliseconds as a threshold to define the synchronicity. And it gives us a 1.68% of false activation rate, according to study 1. So if the start and end offsets of a pair of blink and touch are both smaller than this threshold, they will be recognized as a blink sync gestures. Then here comes the task for the study. We have 3 tasks in the study: blink sync, button touch, and touch only. So blink sync is blink sync, that you perform blink and touch at the same time. And button touch is that you first press the button, then perform a touch gesture. So the reason why we use button touch, we chose button touch as a task, is that it's actually a commonly used technique in commercial products, that when you want to switch between apps, you will first press the hardware button, then select the app you want to switch. And the last task is touch only, which is basically normal touch that we are very used to perform. So the UI will show an arrow on the smartwatch, and the user will have to follow the instruction to perform the gestures. And for button touch, they have to first press the button to disable that green rectangle. Then they can start to perform the touch gesture. Cool. So the results showed that the success rates were all near perfect for each techniques. So meaning that blink sync is actually easy to perform. And there's no significant difference between the touch gestures, the type of touch gestures, like directions or tap or swipe. And if you look at the completion time of each task, of course, touch only is the fastest because it's just pure touch. Then the second is blink sync, then the button touch. So notably that blink sync only adds 0.15 second overhead to normal touch, but it's also 33% faster than pressing the hardware button. So this means blink sync is also efficient to perform. We further analyzed the offsets between the blink and touch events, and we found that the average absolute offsets are well within the 250 millisecond threshold we set for the study, indicating that users are able to accurately synchronize their touch and blink. And the average offset was 75 milliseconds. However, it's slightly smaller for the start offset, and it's slightly greater for the end offset. This might actually indicate that we can choose different threshold for the start and end offsets in the future if we want to deploy this technique to the devices. So we also look at the offsets to true positive rate relationship. So if you look at this graph, we can see that a true positive rate of 97% is achieved when the offset is set to 250 millisecond threshold. And also we can see that the standard error starts to converge when the threshold is beyond 250 milliseconds. So that means this threshold is a good threshold, right? Combining this data with the results from the study 1, we can plot the ROC curve showing the relationship between true positive and the false positives at different offsets value. So based on this data, we suggest future implementations consider our chosen offset, which is 350 milliseconds. So that's about the study. So you might be wondering that what can we use Blink Sync for, right? So let's look at some mock-up apps using Blink Sync. So firstly, Blink Sync actually occupies a unique application space where Blink and Touch delimit each other. Therefore, we see two key classes of use for Blink Sync gestures. The first one is Blink augmented touch input, and the second one is touch augmented gaze input. So let's first start from the Blink augmented touch input. So we developed a mock-up app for Smartwatch Shortcuts on system-level functions, such as calling the main menu or switch between apps. These functions are usually achieved by pressing hardware buttons on smartwatches. However, you can't really put that many buttons on the smartwatch, but you have actually a lot of system functions. So with Blink Sync, we can enable more system functions to be performed instantly. So here's a short demo video for that.
Blink Sync left and Blink Sync right cycles between recently used applications. Blink Sync down terminates the current application. Blink Sync up shows all recently used apps. Note how users can still use normal touch to interact with the watch.
Great. Then after Blink augmented touch input, we got touch augmented Blink input. So we develop applications to use Blink Sync for smart environment control. By looking at an appliance and performing a Blink Sync gesture, you can activate different functions for that appliance. Here's an example using Blink Sync to control Philips Hue light.
To activate the device, users look at it and perform a Blink Sync up gesture. A Blink Sync tap gesture changes the light setting, in this case color. A Blink Sync down gesture deactivates the device.
And we also explored the idea of retrieving a contextual user interface. So if the user was looking at a device and performed a Blink Sync gesture, a UI will be extracted from the devices to the smartwatch.
When a user looks at a speaker and performs a Blink Sync tap, a control UI pops up on the smartwatch for the user to control.
And finally, Blink Sync can also be used to transfer information from a smartwatch to other displays, such as laptops or televisions.
When the user receives a notification containing a link, they can look at the desired display and perform a Blink Sync up, and the associated content will be opened on the screen, revealing the complete details of the message.
So yeah, that's it. That's for the applications. And now I'm going to discuss a few common questions surrounding Blink Sync. The first question that a lot of people asked was the eye tracking technology. So in our prototype, the user needs to wear an additional eye tracker glasses. So it's not that accessible to common users, you know, like normal people who don't have that kind of devices. But fortunately, a Japanese company called Jeans, they have developed a model of eyeglasses that is embedded with EOG, which is able to detect eye blinks. And the glasses look just exactly similar to a common eyeglasses that people would wear every day. So this makes Blink Sync possible to be used by a wider audience in the near future. The second thing I want to discuss is how to avoid conflict with normal touch when using Blink Sync. So we know that for the interaction that consists of multiple events, for example, multi-touch gestures, the first touch of that gesture will have to wait for a short time for potential following touches before recognizing the gestures. So this also applies to Blink Sync gestures because there might be a potential following blinks after a touch. So the gesture recognizer needs to wait a short time before classifying. So every normal touch interaction would therefore have to wait for a short period to be executed. And this will be frustrating. So we came up with a way to handle the conflict. It's a pretty simple algorithm here. So let nt equals to the end time of a touch. So at that time, if the user's eyes are open, we can classify that touch right away. If at that time the user's eyes are closed, we then classify that touch after a short pause to wait for a potential blink. And the rationale behind this algorithm is that if the user finished a touch and their eyes are open, they might have finished the blink, or they weren't even trying to blink. So these are the possible cases. And if their eyes are closed after a touch, that will mean they are performing a blink. So that's the reason why. So if they have finished a blink or they are not trying to blink, then of course we can classify that touch right away. But if they are closing their eyes, then we have to wait for a while to classify that gesture. Okay, so key takeaways here. We present the concept of mutual delimiter, where two modalities are used to jointly delimit the intention of each other's input, therefore increasing their respective input vocabularies or addressing any potential issues of false activations. We also conducted 2 studies showing that it is rare for humans to perform synchronous touch and blink events spontaneously on a smartwatch, while they are actually capable of performing such gestures whenever they want. Right? And lastly, we developed several mock-up applications showing the future potentials of how blink sync can be used to interact with a wide variety of devices. So that's my talk. Thanks for your attention. I'm happy to take any question.
Great, thank you very much, Brian. So again, if people have any questions or comments, you can type them in the chat and I'll ask them, or if you just want to unmute yourself and ask Brian, that would be fine as well.
Sure.
If people... There we are. Hey, Alona. Hello, there's Alona. There we are.
Hey guys, sorry I'm late. Thanks, great talk, Brian.
That was great.
Sorry,
Thank you.
Missed the beginning.
Well, he can do it over again. That's great. Good, yeah. No, that was a fabulous.
Brian, how soon do you think we can implement this in our apps?
Sorry?
How soon can we have this?
Oh yeah, I guess it depends on how soon the Japanese companies shipped out their glasses, right? Yeah, so I would say we are seeing that people are using, eye expression to interact with devices on, mobile phone recently. So I guess it will only take 1 or 2 years that people can use that on other devices.
Oh, we have a question from Jim Lewis in the chat here. He says, so one question here is,
Size of target. That's
yeah,
a good
yeah.
question.
So have you investigated how this works when users need to select from a matrix of small targets?
Yeah. So the thing is that we do not consider this kind of gestures to be performed with this extremely small items. We actually consider that these kind of gestures could be used to perform more high-level functions, as I said in the talk, like system functions that you don't really need to select the items that precise. So, and as you talked, that when doing this gesture, they will be closing their eyes. So that would be super hard for them to select tiny items.
Good, good. Yeah, great question. Thank you.
Yeah.
Any other questions or comments? All right. Well, maybe I will stop the recording here.